Hi, it's Stuart Veach here from OPEX Solutions. Today I wanted to explain how Total Productive Maintenance, or TPM, links with lean manufacturing. To start with, I'm going to define what I mean by lean and give a brief overview of waste. From this, I'll explore the often used model of the sea of inventory and the so-called rocks. This will then lead into an introduction to the 16 losses and then how TPM supports the reduction and prevention of these losses. So, let's get started. There are quite a few definitions of lean, and the one I've chosen is from the FT guide written by Andy Brophy. Here, lean is defined as a way of collective thinking that methodologically stamps out waste while simultaneously maximizing value. The word I would like to draw your attention to is waste. Waste is a very specific term used to define all unnecessary work. In fact, waste can be further subdivided into 7 specific categories. These 7 wastes were originally defined by Taiichi Ohno and are described in his book, Toyota Production System Beyond Large-Scale Production. The 7 wastes are overproduction, making ahead of schedule and making more than is required; inventory, all unnecessary raw materials, work in progress and finished goods; transportation, unnecessary moving and handling of parts; process waste, overcomplicated or unnecessary processes; idle time, operator and machine waiting; operator motion, excess reaching, twisting, turning, bending, walking; and finally, bad quality, that is, scrap and rework. Sometimes this is represented by the sea of inventory diagram. Here, the inventory, raw materials, work in progress and finished goods, is represented as the sea, and this sea has a cost. The process of manufacture and logistics is then represented by a ship that travels on the sea of inventory, and by the look of this graphics, it's quite a bumpy ride. But why is the sea as deep as it is? Well, under the water there are rocks, and the sea level is there to protect our process from these hazards. If we were to reduce the level of inventory and thereby liberate cash into the business, there is a possibility that the process would fail and therefore not be able to meet customer requirements in terms of quality, cost, and delivery. So what are these rocks? Well, they could be many things. In this example, I've chosen poor quality, bad planning, lack of skills, long changeover, large batches, and poor reliability. So what could we look like in the future? As the rocks are smaller, so the level of inventory can be reduced, and this in turn would typically lead to shorter lead times, or in this analogy, a faster ship. This would therefore mean an improvement in quality, cost, and delivery. So how does TPM fit into this? Let's go back to this inventory and the rocks for a minute. These rocks could be termed losses, issues that impede production efficiency and therefore impact our quality, cost, and delivery performance. Within TPM, these losses are specifically defined. There are 16 losses as defined in TPM, and they are grouped into 3. The orange are the losses associated with machines, the blue are the losses associated with manpower, and the green are losses associated with material. Have a look at them just for a minute. How many of these do you recognize in your production processes? So, if the 16 losses are the rocks under the sea of inventory, what is the relationship between the 16 losses and the 7 wastes? In this table, I've tried to show what I believe to be this relationship. Some of the relationships are direct, such as the loss of defects and the waste of bad quality. Some are indirect, such as the loss of breakdown and the waste of inventory. And some I don't think there is a relationship, such as the loss at startup and the waste of transportation. For those of you unfamiliar with total productive maintenance, here's a diagram showing the standard 8-pillar model. A pillar is simply a particular work stream, such as autonomous maintenance, where operators take increased ownership for their equipment, or focused improvement, where losses are analysed and teams formed to then attack the identified losses. The 8 pillars combine together to synergistically improve production efficiency. The pillars combine improvement and maintenance approaches so that improvements are sustained in the long term. Just going back to the rocks example from before, how would TPM pillars help attack these? Well, let's look at each in turn. First of all, we have poor quality. We might use a combination of focused improvement, quality maintenance, and support this with autonomous maintenance and training education. For lack of skills, we may use autonomous maintenance, and training and education might be the right and appropriate approach. For poor reliability, and reliability being a critical focus for TPM with the ambition for zero breakdowns, this is usually attacked with a combination of focused improvement, autonomous and planned maintenance, and training and education. Moving away from the physical production process, perhaps planning is an issue. Then deploying the office TPM pillar with focused improvement and training and education might be the right combination. Long changeovers can be a challenge for many organisations. Driving their improvement through focused improvement, autonomous maintenance, training and education, and the Office TPM pillar can often yield great results. And last in our example, long new product and process development could be looked at using the planned maintenance and early management pillars. So just to recap, total productive maintenance can be a critical overall strategy for an organisation to become lean. With the 8 pillars driving cross-functional teamwork and the combination of improvement and maintenance, TPM could be the vital ingredient in your lean transformation. This has been Stuart Veach of OPEX Solutions. Visit our website for more information on lean and TPM and how we can help your organisation achieve great results. Thanks for watching.